let us calculate the work done of this Otto cycle. Okay, and that is the net work done. As we know, the process 1 to 2 is the isentropic compression process, the process on which work is done. Okay, generally work is done on the process, that is work consuming process, that is 1 to 2. Okay, or we can say we supply work to accomplish this process 1 to 2 process, and this 3 to 4 process is process of this isentropic expansion process, and from which we generally get the work. Okay, and so we can write down this, this is the work done. If we want to calculate the work done, then we can generally define it like this, that is work received from this process. Okay, this is from this adiabatic process, reversible adiabatic process 3 to 4, minus, okay, the process work received from this process 3 to 4 minus work consumed by this process 1 to 2. And we already know from the basic thermodynamics, okay, that is the total work done by this process, okay, work done or work consumed by this process, and total work delivered by this process. As it is the reversible adiabatic process, then the work done in this process 3 to 4 will be like this, that is P4 V4 by minus P3 V3 divided by gamma minus 1 minus P2 V2 minus P1 V1 by gamma minus 1. Now let us generally do some simplification of this equation. Okay, let us take common P1 V1 by gamma minus 1. Okay, then it will become P4 V4 by P1 V1 and then minus P3 V3 by P4 this will become P1 V1 minus P2 V2 by P1 V1, and then again minus, okay, this will become P1 V1 by P2 this will become P1 V1 by P1 V1, and this will become plus. Okay, this will become because this is minus that will become plus. Okay, now let us recapitulate some basic fundamentals of thermodynamics that is generally associated with these processes. Okay, if we consider this process 1 to 2 and 3 to 4, 1 to 2 process and 3 to 4 process, এই দুটো প্রসেস যদি আমরা কনসিডার করি তাহলে আমরা কি পাবো, দেখো দি আমরা থার্মোডাইনামিক রিলেশনটা কি পাচ্ছি। both processes are isentropic process, reversible adiabatic process, so we can say that is P1 V1 to the power gamma is equal to constant and P2 V2 to the power gamma is equal to constant, and in this process also P3 V3 to the power gamma is equal to constant and P4 V4 to the power gamma is equal to constant. So from this we can generally write that is P2 by P1 is equal to nothing but V1 by V2 to the power gamma, and from this that is P3 by P4 is equal to V4 by V3 to the power gamma. This is nothing but R to the power gamma, this is also R to the power gamma. So we can write P2 by P1 is equal to P3 by P4 is equal to nothing but R to the power gamma, because this V1 by V2, that is the total volume by the clearance volume, which is generally termed as the compression ratio and which is denoted by this R. Okay, so we can write this. On the other hand, if we consider this is the one way, and at the other hand, if we consider the process, the two processes, this is heat addition process, then we will find the pressure ratio, and pressure ratio as defined like this, pressure ratios. Okay, what will be the pressure ratio? Pressure ratio will be P3 by P2, and that is equal to P4 by P1, P4 by P1, and let us say this is RP. RP is nothing but this is the pressure ratio, and we will use these two, pressure ratio and this compression ratio and this equation R to the power gamma, to simplify this whole equation. Okay, to simplify this work done equation. Okay, so let me clear and write down these two. Okay, one is the pressure ratio and another one is the generally compression ratio. The related term, the pressure ratio is nothing but P3 by P2 is equal to P4 by P1 is equal to RP. Let's say this is the pressure ratio and this is the compression ratio, which we have already defined these two. Okay, now from this we can write this gamma minus 1. Now let us simplify with this. Okay, now you will find we can write this like this, RP into R to the power gamma. If we write, this is the P2 by P1. Okay, if we write this P4 by P1, P4 by P1, this is nothing but the P3 by P2. Okay, this is nothing but P3 by P2. Okay, P4 by P1. Okay, let me write this. This is not the correct. This will become. Let me correct. This will become P3 V3, P4 V4. Okay, this will become P3 V3. This will become P4 V4. Okay. Okay, this is the correction. Please make it correct. Okay, this is the adiabatic process, and pressure is generally pressure and volume, the combined. This is P3 and V3. The product of P3 and V3 is larger than the or higher than the P4 and V4. Okay, so it will become now this is P3 by P1, and this P3 by P1 can be write like this. Okay, that is P3 by P2 into P2 by P1. We can write this. Okay, this P2 will be cancelled. Now it will become like this, the P3 by P2. What will the value of the P3 by P2? That is generally RP, and the value of P2 by P1 is nothing but R to the power gamma. Okay, so we can rewrite this P3 by P1 as RP into R to the power gamma. Okay, and you can see the compression ratio, which we have already discussed, the compression ratio, that is generally V1 by V2 is equal to V4 by V3, and where this V2 is equal to V3 and V1 is equal to V4, and that is equal to R. Okay, nothing but R, that is the compression ratio. And now we can see as V2 is equal to V3, then we can write the V1 by V3 is equal to R. Okay, or we can write this V3 by V1 is equal to 1 by R. So we can write this V3 by V1 is equal to 1 by R. That means R will be R কোথায় হবে, R নিচে হবে, ডিনোমিনেটরে R আমরা পেয়ে যাব। বোঝা গেল? And this is how we can simplify this in terms of pressure ratio and the compression ratio. We want to simplify this equation in terms of pressure ratio and the compression ratio. Now look at the next term. Okay, what is the next term? P1 and P4 and P1. What is P4 by P1? P4 by P1 is nothing but that is generally RP. Okay, rp, that is the pressure ratio of pressure, okay. And v1 is nothing but, you can see v4 is equal to v1, that means this will be cancelled out, so this term will be generally only rp, এখানে শুধুমাত্র আমরা rp পাবো, কেননা v4 আর v1 যে দুটো সমান আছে এই দুটো সমান কেটে যাবে, তাহলে p4 by p1 will be generally rp only, that is the pressure ratio. And next term is p2 by p1, okay. You can see this p2 by p1 is nothing but that is the r to the power gamma, and v2 by v1 again this is generally r, okay. As we know v1 by v2 is equal to r, or we can write v2 by v1 is equal to nothing but 1 by r. This is how it becomes r to the power gamma by r, and plus this is 1, okay. Now we have simplified total equation, okay, total equation of the work done in terms of pressure ratio and the compression ratio, okay. Now let us do some more work to look it more attractive, okay. So we can memorize this equation, okay, which will be needed in case of solving the numerical problems, okay. নিউমেরিক্যাল যখন আমরা সলভ করব তখন কিন্তু আমাদের কিছু কিছু ক্ষেত্রে এটা লাগবে, তো আমরা আরও কী করে এটাকে সিম্পলিফাই করি দেখা যাক। তো rp into r to the power gamma minus 1, we can write this easily minus rp, and this will again become gamma minus 1, r to the power gamma minus 1 plus 1, okay. If we take common p1 v1 to the power gamma minus 1, if we take common from this, okay, you can see this will become, if we take common rp, then this will become r to the power gamma minus 1 minus 1, okay, from this term, and minus r to the power gamma minus 1 minus 1, this will become this, okay, p1 v1 gamma minus 1, and total this will become rp minus 1 into r to the power gamma minus 1 minus 1, okay. So we can say this is the final equation for the work done in case of Otto cycle. In case of Otto cycle, this is the final equation for the work done, and you can see from this equation the function, the work done is the function of pressure ratio and the compression ratio, and that is to some extent dependent on this p1 v1, the primary pressure and the volume, okay. This is the total volume of the cylinder, okay. If we increase the total volume of the cylinder, then the work done received from the engine will be higher, and if we increase the pressure, okay, initial pressure, the pressure at the beginning of this compression, then this will generally result the higher work done, okay. And this is the equation for the work done. And now let us calculate the mean effective pressure, okay, and this is how we can calculate the work done. And now let us calculate the mean effective pressure, okay. How we can calculate the mean effective pressure, okay. Mean effective pressure is defined by the ratio of work done to the swept volume, okay. Swept volume, what is swept volume? That is also called the displacement volume. We will be discussing all this thing in case of performance of engine, what is swept volume, what is clearance volume, what is total volume, okay, what is generally cubic capacity. We will be discussing all this topic in case of performance of an engine, okay. Let us generally remind that the mean effective pressure, the pressure, the average pressure which is available on the cylinder, that is generally called the mean effective pressure, okay, at the time of the expansion process, So how we can generally, this is mean effective pressure, how we can calculate that mean effective pressure, we will be discussing this mean effective pressure, mean effective pressure, okay. And how we can calculate this mean effective pressure, this is generally denoted by p suffix m, okay, and this is generally defined as the work done divided by swept volume. Okay, swept volume, work done, we have already calculated the equation for the work done. Okay, we have already calculated the work done equation for the work done. Let me write down that equation. If we want to rewrite this equation, this will be like this. This is P1 V1 by gamma minus 1, okay, into Rp minus 1 into R to the power gamma minus 1 minus 1. This is the equation for the work done. Okay, and swept volume, what will be the swept volume? Swept volume is the volume, the displacement volume, যে piston top dead center থেকে BDC তে যে ভলিউমটা ট্রাভেল করছে reciprocating movement দ্বারা, that volume is generally called the swept volume. Okay, now you can see from this diagram very clearly. Okay, at the point if we mark this as this is the bottom dead center, this state 1 4 this point 1 is the bottom dead center, and this point 2 is as the top dead center. Then the travel, the distance between these two or volume between these two, this amount of volume is generally called the swept volume. Okay, and that is generally a gate, by the difference of V1 total volume and the clearance volume. Okay, if we deduct the clearance volume from the total volume, then we will get the swept volume. Okay, so how we can define this swept volume? Swept volume is defined as the difference between the total volume minus clearance volume. Total volume is nothing but that is V1 is equal to V4. We can write this V4 also, but let us consider V1 here, V1 and V2 is nothing but the clearance volume. V2 and V3 both are the clearance volume. Okay, if we deduct this clearance volume V2 from the V1, then we will get the swept volume. The displacement volume or the swept volume, the volume which is generally in between top dead center and bottom dead center, যেখানে পিস্টন বটম ডেড সেন্টার থেকে টপ ডেড সেন্টারে যাচ্ছে, যে ভলিউমটা অতিক্রম করছে বা টপ ডেড সেন্টার থেকে বটম ডেড আসার সময় যে ভলিউমটা অতিক্রম করছে, that is generally called the swept volume. And now we know that is V1 by V2 is nothing but that is R, that is the compression ratio, total volume by the clearance volume. So we can write V1 is nothing but R into V2, and we will use this in case of this. We want to depict this in terms of compression ratio also. Okay, in terms of compression ratio and P on V1. Okay, now V2 R minus V2, that will become V2 into R minus 1, or we can write down this is the swept volume. Swept volume is defined as the V2 into R minus 1. Now we know the work done, that is P1 V1, okay, gamma minus 1, that is divided by gamma minus 1. Let me write down here gamma minus 1 into R to the power P minus 1, that is the pressure ratio minus 1 into compression ratio to the power gamma minus 1 minus 1. Okay, this is the equation for work done. We have already calculated the equation, or we have already derived this equation. Okay, and swept volume, what is the equation for the swept volume? We have already generally it is also derived, that is swept volume is equal to V2 into R minus 1. Okay, this is V2 into R minus 1. Okay, now let me clear this. Okay, this is generally work done, and this will become R to the power gamma minus 1 minus 1. Okay, now is equal to P1 V1 divided by gamma minus 1 into, this is gamma minus 1 into V2 into R minus 1. This is the we can rewrite this equation as like this. Okay, আমরা এইভাবে লিখতে পারি। তারপর দেখো এখানে উপরে কি ছিল, R to the power P minus 1 into R to the power gamma minus 1 minus 1. Okay, now this V1 by V2 is nothing but V1 by V2 is what? This is R. This is the compression ratio. So we can rewrite this ratio of V1 and V2 into the R. Okay, this is nothing but the R. So P1 into R into Rp minus 1, Rp minus 1, this is not Rp minus 1, and this is R to the power gamma minus 1 divided by gamma minus 1 into R minus 1. Now you can find that the mean effective pressure is the function of compression ratio, specific heat ratios, and the initial suction pressure. Okay, we can say the suction pressure at state 1. Okay, and this is how we can calculate the mean effective pressure, okay, of an Otto cycle, and we have already derived the work done, okay, of the Otto cycle, mean effective pressure, and the efficiency, the air standard efficiency of the Otto cycle.